The Bell telephone system brings you one of a series of programs on science. Man's effort to understand nature's laws.
Let's try that focus again, Jim.
Coming up.
Title's okay. Now let's test that first animation. Roll 2. Okay, hold it. Now sharpen the focus. Right. Hold roll 2.
Doctor, how was the sun born?
Don't know exactly.
You're a scientist and you don't know?
Could use my imagination, but you're the fiction writer.
Imagination? Well, we could ask Mr. Sun himself.
Yes, if we had a magic wand.
Sure, you've got it. Magic. Your science and my magic. We'll open up our story of our Mr. Sun with a little fantasy. You know, showmanship. Go back into time, show the birth of the sun, out of time, stardust. Here, we'll turn back the clock.
Ooh, that'll only take you back 12 hours.
Oh, well, all right. We'll open up the curtain of our imagination. This'll be our magic screen. Yours will be just for facts. We'll pull back the curtains of our magic screen. We'll dream up a clock. There you are. A clock that's been ticking since time began. Our solar system, wound up by Father Time himself.
Do you see what I'm seeing?
Well, certainly. Maybe I could talk to him, huh? Hey, Father Time, how long has that sun clock been going?
A few billion years. Why?
Well, could you unwind it for us?
Unwind time? Man, are you crazy?
Well, I'm a fiction writer. We're auditioning a show about our Mr. Sun, and I thought that...
Show about me? Well, about time.
Look who's here. Hi. Yeah, we were wondering how it all happened at the beginning.
Nobody knows what happened at the beginning.
Oh, come on, Pop. Unwind us. They want to see how I was born.
You old hot gas bag, you keep still.
Now, don't flip your sickle, Pop. The man says it's just a show.
He's a romantic fool. If you want facts, ask your scientists.
Oh, we've got Dr. Research here for facts, but what I need right now is something to open this thing up with a bang. You know what I mean?
Certainly. My story should be colorful, romantic, not just facts. Here, I'll tell you how it should open.
Wait a minute, I'm telling this story. You're just imaginary.
Quiet! You want a show, don't you? Go on!
Yes, sir?
Set the stage for me.
Oh, yes, sir.
Get an Academy Award ready.
Hey, he's taking over. How do you like that?
I like it. Let him go on.
Music. Lights. Color. Enter Mr. Sun from the east.
Good morning, Brother Earth. For the umpteenth billionth time, good morning. Good morning, Brother Bird, Brother Mountain, Brother Sea. Morning to you, Brother Gull, Brother Bee, Brother Fish. Good morning, all of you. Great day. Every day's a great day. You know me as the sun. Of course, what I really am is a star. An average, everyday type of star. Billions like me. I remember when primitive man first began to look up, to gaze in wonderment at the stars and planets sweeping across the face of the sky. That primitive curiosity was the beginning of all your science. Of course, they had some pretty odd notions about me. Some thought I was an enormous beetle trundling a fiery ball across the heavens. The ancient Eskimos thought I was a little man wearing thick furs to keep myself warm. But to most, I was a god. Fancy names and wardrobes. In Babylon, I was Shamash, and my sun temples were observatories. In Persia, I was Mithras, and to ancient Egypt, I was the great god Ra. Glory to the great sun god.
O thou perfect, thou eternal, thou only one.
Blame me for getting the swell head? But the name I liked best was Phoebus Apollo. The Greeks always did have a word for it. In my case, it was handsome. Apollo racing across the sky in his fiery chariot, making heavenly music on his golden ukulele. Oh, that was for me. I loved it. And then along came another Greek to spoil it all. A Greek who would rather think than worship sun gods. Anaxagoras was his name.
The sun is not a god or a person. It is a mass of red-hot stone, only 40 miles across and 4,000 miles away.
For blaspheming against the beautiful Apollo, Anaxagoras was banished from Athens. And I wasn't a bit sorry for him. But man had fallen for this new and fascinating mistress, his brain. Thinking began spreading like the measles. Everybody got the bug. The Greeks with their logic and philosophy, the Hindus with their algebra and your present number system, the Arabs with their early instruments like the astrolabe. And today, instead of temples, rituals, and hymns to the sun, it's domes, gadgets, charts, and numbers. I'm demoted to a specimen, a pile of facts and figures. A big blob of mass holding little blobs of mass together with gravity instead of with love. I think you're all through.
Who's all through?
Earthman, he's had it.
Why, you flaming idiot, they haven't even started yet.
In worshiping me, ancient man was reaching for the great light beyond. But modern man, he's got all the answers.
Mr. Sun, you mind if I butt in a moment?
Who are you?
Who, me? Oh, I'm the... Never mind. Thank you very much. Goodbye.
Would you mind if we listened in?
See here, you're not even real. I just made you up. You go wind your clock.
No, let them stay. I like your magic. Father Time, my name's Research.
Who?
A scientist. Howdy, Dr. Research. I'd like to hear what you have to say about Golden Boy here.
Well, it's a delightful experience talking directly to you and to Mr. Sun, especially for a scientist. I was just going to relate a few facts about Mr. Sun.
Facts. If you're going to tell my story, don't give the people equations and figures. Give them the real lowdown. Tell them what I mean to them. They've forgotten that. When they eat corn or bread or grapes or meat, they're eating sunlight. Their houses, furniture, cars, their nylons. Yes, even their moonshine is sunshine. Tell them if it wasn't for me, they'd have no eyes, because there'd be nothing to see.
That's enough. You're getting purple.
Why, if I put my light out, every living thing on Earth would be frozen stiff. And you scientists who know would be just as cold and stiff as the people that don't know.
Through blowing sunspots?
Yes.
Then apologize to Dr. Research.
Oh. Well, I'm sorry, Brother Research.
No apology necessary. Mr. Sun is almost right.
Almost?
Yes, Mr. Sun, your logic is a little on the romantic side, too. You say that you don't like facts, and yet you've just given us quite a list of them.
Oh, this may turn out to be fun.
No, Mr. Sun, we haven't got all the answers. Science has just opened the book. Yet in seeking for more knowledge, we too, in a way, are reaching for the great light beyond.
Doctor, that's it. That's it.
What's it?
The gimmick. Come into my office here. We put the show on for him.
For the sun?
Sure, it's a tough audience. Science shows, son, we're not all through. You get it?
Could be boring to him.
Could be.
You keep your corona on. What science has found out about you is more exciting than any fiction. You stick around, you'll see.
But we really don't know very much about him.
Oh, we know plenty about it.
What about the television people?
Never mind them. If this thing goes, we got a real show here.
Well, you remember where you come in.
I remember the weather, the fuel,
And
the
you
energy.
cut in on me if I get stuffy.
I'll cut in on you. But come on, roll them.
Roll 2. Here we go. Although Mr. Sun is 93 million miles away, and it takes his light 8 minutes to reach us, he's really quite close. The light from the next nearest star, traveling at 186,000 miles per second, takes over 4 years to get to us. We know Mr. Sun is so large, our Earth is barely visible alongside him. It would take some 340 worlds like beads on a string to make a necklace around his shining sphere. How much does Mr. Sun weigh? 1,000 worlds? 100,000? No, sir. He weighs as much as 330,000 Mother Earths. We also know that Mr. Sun is not solid or liquid, but a fiery ball of hot, glowing gases, consisting of some 95% hydrogen and helium and a few percent all other elements. We know that this huge cloud of hot gases would expand, float away, dissipate into space, unless gravity squeezed it together into a tight sphere. The gases at the center of the sun are so densely packed by gravity that they're about 100 times heavier than water. And the pressure is around 1 billion tons to the square inch. While at the surface, the gases are so thin, the pressure is only about 1 pound to the square inch. We know, too, that the temperature at the core of the sun is incredibly hot, around 30 million degrees Fahrenheit, while at the surface, it drops down to just about 10,000 degrees. But here's a strange thing. As we go out from the sun into the corona, the temperature goes up again to over 1 million degrees at the outer edges.
Tell them why, Dr. Research.
We don't know why.
You don't? Well, what is the corona, anyway?
We don't actually know that yet.
Oh?
But we do know there's more to Mr. Sun than the shining surface we normally see, which we call the photosphere or sphere of light. Only when the moon moves between us and the sun and covers the photosphere completely in a total eclipse can we see the rest of Mr. Sun's thin atmosphere, the beautiful and mysterious corona. For many, many years, scientists have lugged their instruments to all parts of the globe, chasing eclipses. Expeditions spending months just for a 2 or 3 minute opportunity to see, measure, and photograph the eclipsed sun. Sometimes heavy clouds, failure, complete washout. Sometimes light clouds, measurements uncertain. But on happy occasions, perfect conditions. The corona is studied and photographed in the fullness of its glory. Your corona is most puzzling to us, Mr. Sun. We know that it rotates with you, but at no 2 eclipses does it look just the same. It pulsates, changes shape, and at times extends out millions of miles.
Why is that?
Just one of the many things we still don't know about the sun.
Look, hadn't we better tell them something we do know?
Want to hear any more, Mr. Sun?
I like your pictures of me. Got any more?
Oh, yes, lots. Roll 6. The camera's one of our main tools. Now, here's a normal picture of you taken by direct sunlight. It's rather flat. Your face has little expression. But about 60 years ago, Dr. George Ellery Hale of America and Dr. Henri-Deslandres of France conceived this ingenious instrument called the spectroheliograph. It filters out all the light waves except the light from some particular glowing atom, as for instance, hydrogen. Let's look at a normal white light picture of the sun again. Now here, taken at the same time, is a spectroheliogram that photographed only the red light from glowing hydrogen atoms. Now your face is interesting, reveals character. Here's another spectroheliograph taken at the same time that photographed only the violet light from incandescent calcium atoms, which tells us even more about you. With the spectroheliograph, Dr. Robert R. McMath of the McMath-Hulbert Observatory near Pontiac, Michigan, made the first time-lapse motion pictures of the prominences and wrinkles on the face of the sun. From his pictures and from the many thousands of photographs taken at observatories all over the world, particularly at the Mount Wilson Observatory, we've learned a great deal about Mr. Sun, especially about those much talked of sunspots that mystified Galileo.
Ah, sunspots. There are such things, of course.
Oh, yes.
They're not just something that scientists see when they're tired.
Oh, they're very real, but very mysterious. They mystified Galileo when, through his original telescope, he first saw them moving daily across the face of the sun. And they've been mystifying us ever since. Spots can appear singly, like this one, or in groups like these, and quite often in distinct pairs. When photographed by red hydrogen light, they look something like giant, violent tornadoes seen from above. Spots range in size from mere pinpoints just a few hundred miles across, into which you could drop the British Isles, to huge ones, into which you could drop 100 planets as big as the Earth. Spots look dark, although they really aren't, because they're cooler than the rest of the surface. 7,000 degrees as against 10,000 degrees of the surface. Also, over the years, we notice a strange fluctuation in the number of spots, increasing to a maximum, decreasing to a minimum, in more or less regular 11-year cycles, which many of us believe affect our weather, our crops, and the growth of our trees. One of the most astonishing mysteries revealed by study of spots, Mr. Sun, is that your equator, or the middle of you, rotates faster than the rest of you.
The middle rotates faster?
Yes. For instance, if a line of spots were placed like runners at a starting line, from the sun's north to the South Pole, and at a signal raced around the sun, they would end up like this. Equator winds in 25 1/3 days. Half north and half south tie for second. Time, 27.5 days.
Why is that? You don't know why. Okay.
Have you got any more pictures of me?
Hey, would it please you to know, Mr. Glory Puss, that you've been photographed more than all the Hollywood stars put together?
The most dramatic pictures, roll 7, the most dramatic pictures are taken with a coronagraph, which creates automatic total eclipses whenever the sun is shining. This very remarkable instrument was first constructed by Dr. Bernard Lyot of France in 1930. Today, there are improved coronagraphs at the High-Altitude Observatory at Climax, Colorado, under the direction of Dr. Walter Roberts, and at the Air Force installation at Sacramento Peak, New Mexico, presided over by Dr. J.W. Evans. The first user of the coronagraph in America was Dr. Donald H. Menzel of Harvard University. What happens in these red hydrogen coronagraph motion pictures in 1 second actually took place in about 5 minutes on the sun. The small sphere you see here represents the size of the Earth in comparison with the sun. Your surface, Mr. Sun, is a stormy sea of violent motion. Small spicules or geysers like these continually burst from blisters on the surface and jet up like little fountains, if you can call 5,000 or 10,000 miles up little. Compare them with the size of the Earth. Big flame-like eruptions like these are called prominences. They're vast clouds of gas that sometimes float idly, at other times shoot out at thousands of miles per minute, as if they never heard of gravity. Sometimes they rise in graceful ribbons or tangled streamers.
Beautiful, beautiful.
Some surge up like gigantic geysers. Others flow sidewise and downward, at times forming natural bridges. Portions of the prominences may even break off and go floating away, as in this picture. But the baffling part is that most prominences flow downward, gases materializing from seemingly nowhere and flowing down into sunspot areas for days at a time. Coronal rain, it's sometimes called.
Where does it come from?
Of course, when it rains on Earth, we don't actually see the rain go up either. We only see it come down, although we know it evaporates up from the 7 seas. But where coronal rain comes from, we can only guess as yet.
Give him the whopper, Doc. Biggest solar explosion ever recorded. Greatest photographic shot in history.
On June 4th, 1946, a great arch of gas, hundreds of times as big as the Earth, rose up at a speed of 400,000 miles per hour. The arch expanded clear out of range of the instruments at Climax in less than an hour and a half.
I remember that one. Sure blew my top that day.
Yes, we heard you. Roll 15.
You heard me?
Oh, yes, we hear you every day. You not only send us light waves, but you broadcast radio waves, which we are able to pick up quite clearly at special radio astronomy stations, which receive radio signals from outer space. Here's a sample of the radio message you send us on one of your noisier days. In Australia, they've recently done some brilliant work with radio astronomy. Dr. E.G. Bowen heads the group of radio astronomers. It's only in the past few years that we have discovered some strange things in the sky. Radio waves coming to us from many places in outer space. Radio astronomy is a brand new exciting tool for scientists, and with it we found out quite a bit about you, Mr. Sun, through the noises you make.
I'm beginning to feel like a goldfish.
You got him going, Doctor.
Well, doesn't all this spouting and erupting have some effect on the Earth?
Oh, yes, tremendous
Doctor.
effect. Roll 8. Well, for instance, when a large flare flashes up around a sunspot area, it immediately sends out a burst of powerful ultraviolet rays that hit the Earth in 8 minutes. But it also sprays streams of slower electrified fragments of atoms out into space as if from a hose. This solar spray of fine particles usually misses the Earth, but at times the Earth is in its path. Now, the Earth is a magnet with north and south magnetic poles and a magnetic field around it. The spray of minute particles shot from the sun, which takes some 30 hours to reach the Earth, is deflected toward the poles by the Earth's magnetic field. As this solar dust, stardust you might call it, comes down into our atmosphere near the poles and collides with air molecules, it creates the most beautiful spectacle of the aurora, also called the northern and southern lights. Dr. C.W. Gartline of Cornell University took this unique time-lapse motion picture of the actual aurora borealis. The Earth's rotation produces the apparent motion of the stars in the background.
But the effects of these ultraviolet bursts from the sun are not so beautiful. Voltage fluctuates, radio communications are disturbed, and although our radio engineers have performed near miracles in protecting our radio waves from this solar sniping, Doctor.
Roll 7C.
Sometimes this happens.
We take you now to London for a direct report from Sam Johnson. Come in, London.
This is Sam Johnson. There's an air of tense expectancy here in London. This morning, the Prime Minister...
Will you stop playing with that radio?
I ain't even touched it.
Well, then do something.
That was the momentous statement the Prime Minister read to us this morning. And now, back to New York.
What an engineer.
Wasn't the shoe.
No, it wasn't the shoe. Let's recreate what actually happened in terms of atmosphere and radio waves. Radio waves normally move in a straight line, but about 50 miles high in our atmosphere, there's an electrified layer called the ionosphere that reflects radio waves, making it possible to bounce them around the Earth. Now let's listen to Sam Johnson again.
This is Sam Johnson. There's an air of tense expectancy here in London.
Suddenly a bright flare occurs on the sun. A burst of ultraviolet rays disrupts the ionosphere.
This morning, the Prime Minister announced...
But radio engineers are right on the ball.
Bill, London's folding. Another SID, huh? Yep. I've got another frequency ready for you. Not yet. Wait it out a minute.
An SID means a sudden ionospheric disturbance, which is unpredictable. But usually in a matter of minutes, the ionospheric layer reforms again.
And that was the momentous statement the Prime Minister read to us this morning. And now back to New York.
But when big regions of the sun are intensely active, the spray of solar particles that causes the aurora can disturb communications for hours, even days.
But this type is predictable.
Oh, yes. Fortunately, it usually is. And since radio communication is so vital to the services, airlines, radio stations, telephone companies, ships at sea, recently observatories all over the world have begun to keep watch on the sun and make up a worldwide radio warning service. At the High-Altitude Observatory at Climax, Colorado, at the Air Force Observatory at Sacramento Peak, at Kodaikanal, India, in Japan, in stations all over the globe. Observers keep tabs on you, Mr. Sun, and send in information to the central collecting agencies, such as
the Radio Storm Warning Service of the National Bureau of Standards, where men under Alan Shapley analyze the data and try to predict when the solar storm will strike the Earth, especially the vital North Atlantic communication lines. Then by radio, by teletype, by phone, the warning goes out. Severe magnetic storm will affect North Atlantic circuits. Lower frequencies or use southern routes.
That's fine. But, Dr. Research, what has puzzled you scientists most about the sun?
Roll 9.
Oh, yeah. Even I can give you that in one word. Energy. This lady's parasol has 1 1/2 horsepower of sunshine continually poured on it. Enough to run her washing machine, sewing machine, refrigerator, and vacuum cleaner. In full sunlight, our family car receives almost enough sun power to run it, if we only knew how to use solar energy directly. At the common rate of 2 cents per kilowatt hour, the sun sends the Earth $1 billion worth of energy every second, and it's coming to us free. 5 minutes worth would pay our national debt. 1 minute's worth of the energy that hits the Earth would pay the total annual income tax of all United States citizens. Oh, a happy day.
And yet what the Earth receives is only a minute fraction of the whole. Only 1 part in 2 billion of the total solar energy. The rest of the 500,000 billion horsepower goes out into space.
How does the sun generate this enormous amount of power, Dr. Research?
Yes, I don't eat, drink, or take vitamins. I never sleep or rest. Then how do I do it, brother scientist?
Well, we know at least part of your secret now.